PowerShell remoting basics. We've got a lot of information to cover. This is one of the coolest features in Windows PowerShell. For me, it's the killer app. This is like the reason to have PowerShell installed everywhere. We've got several nuggets where we're going to break down some of these things, but right now, I want to just start with some basic architecture, some theory of operation, and some very, very basic usage patterns. So we'll start with that basic theory of operation. What this thing is, how it works. We'll cover some of the security around it. I'll show you how to turn it on manually and via group policy object. And along the way there, we'll cover some of the more interesting configuration settings that you can fuss with. And I'll show you how to use this thing in very basic form. We'll do a one-to-one connection between two computers, and we'll do a one-to-many connection to several computers, so we can start to kind of build up that multiple computer management thing, which is really what remoting is just designed to make easier and frankly very cool. So let's start with some theory of operation. Now, from a terminology perspective, we're going to say that you and I are sitting in front of a computer. We'll call that the local computer. And it's often going to be a client operating system because that's often what we've got running on our workstation that's actually at our desk. Now from there, we are going to connect to one or more remote machines. Those might be servers. Those could be computers running another client operating system. It doesn't matter. So long as the remote machine has had PowerShell remoting enabled for incoming connections, we're good to go. We don't need to do any enablement on our starting point on the local machine. Remoting is always enabled for outgoing connections, provided any local firewall software is allowing the connection out, of course. So in terms of protocol, the actual protocol being used to make that connection is called Web Services for Management, WS Management, or more commonly, you'll see it as WSMan. Now, in the Windows operating system, there's a service called Windows Remote Management, or WinRM, that actually implements that protocol. And the protocol is built on top of HTTP or HTTPS. In fact, the default ports are 5985, or if you're using HTTPS, 5986. Now there's two ways to use this. There's the first way, which I call one-to-one, or I guess you could call it interactive or ad hoc, so we'll call it one-to-one for now. And that's me sitting on my client computer connecting to a single computer. Now from a use case perspective, this feels a lot like the SSH protocol that's so common in Linux and Unix operating systems, but it works very, very differently. SSH is basically an evolution of Telnet. What happens is you get your SSH client software running on your computer, you push a button on your keyboard, that gets sent to the server, which echoes it back, which causes it to be displayed on your own screen as well. WSMan doesn't work like that at all. Instead, in WSMan, you're going to type your entire command, and when you hit enter, the entire thing gets bundled up into an XML packet and sent to the remote computer. The remote computer then executes that, does whatever's necessary, takes the results, which, because this is PowerShell, the results are going to be objects. It serializes those into XML. This is not that different from using convert to CLI XML. Now, in fact, the XML format is a little bit different, but you don't need to worry about it because when that XML arrives at your computer, it gets decoded or deserialized back into objects. So from your perspective, it's all objects top to bottom. XML is just used as a way of transcribing those into text so that they can be easily transmitted across the network. Now there are a ton of configuration settings that we can play with on this thing to customize it, and we're going to walk through all of those. The other main use model for this is called one-to-n or one-to-many. And that's where I sit here on my computer and I come up with a command, or I might even come up with a whole script file full of commands, and I transmit those commands to multiple remote computers. They all execute that, and they're doing this in parallel to a degree, and then the results come back to me in the form of XML, which gets translated into objects. So this is really where multiple computer management sets in. And again, lots of configuration options, gonna cover all of them. From a security perspective, this is kind of an important piece, obviously. Let's just focus on this scenario where I'm in a single domain with my client and whatever computers I'm managing. In this case, the default authentication protocol is going to be Kerberos. Now, it means that when I go to connect to a remote machine, I have to refer to it by its actual name as it appears in Active Directory. And that's because the remoting system wants mutual authentication. Now, yes, your credential is going to be delegated via Kerberos over to the remote computer. So whatever you've asked it to do, it is going to do as you. So whatever you've got permission to do, it'll do. Anything you don't have permission to do, it won't do. If whatever you ask it to do would normally be audited, like let's say you ask a domain controller to delete a bunch of Active Directory users. If you normally audit that activity in your environment so that someone deleting users in Active Directory users and computers, well then that same action is going to get audited the same way if you perform that action through remoting. So this doesn't really add anything to security and it doesn't take away anything from security. But there's a trick here. You're sending your credentials to this remote computer. Think about that for a sec. If you've got a family, or you've ever been in a family, then you've probably had an opportunity to loan the car keys to someone. Let's say you're a parent and you need to loan your car keys to your 16-year-old son or daughter. Okay, fine. You're probably you've come to the point where you're at least somewhat comfortable doing that. You're going to hand the keys over. But before you actually hand the keys over, you want to make sure that's actually your son or daughter. And the way most of us do that, just automatically in our brains, is we look at their face. Yep, that's you. And you hand them the keys. Now imagine going out into the school gym one day, and all of the students have got paper bags and masks over their heads. You can't tell who any of them are. They're all wearing identical clothing. They're all the same height. They're all the same weight. You can't tell who any of them are. Are you going to hand your keys out? Well, no, because you can't mutually authenticate. Now, when you hand your keys over, they know it's you handing the keys, but you don't know who they are. Well, remoting feels exactly the same way. It doesn't want to transmit your keys until it knows who's on the other end. In a domain environment, Kerberos handles that automatically, provided you connect to a machine using its Active Directory domain name. Because Kerberos can look up that machine, get all the right certificates in place, and make sure that mutual authentication occurs. That same mutual authentication can occur if you're going to a different domain or a different forest over a trust relationship, because the protocol is designed to do that. Where it all falls apart is if you need to go to a computer that is in an untrusted domain or that isn't in a domain at all. Right there, because we're no longer able to use Active Directory, the Kerberos protocol is out of the question. You might want to choose to use the BASIC protocol. Now, the downside of the BASIC protocol is that your credentials are now being transmitted in clear text. That's username and password, clear text, coming over here. Probably not what you were hoping for. Well, that's okay. Because another problem we have is that there's no way for my computer to mutually authenticate the remote computer. You know, if I say, look, I want to make a connection to FDC, there's no way for my computer to verify that this is in fact FDC. For all I know, it could be some other computer that's spoofed DNS and is intercepting my connection to FDC, and it's waiting for me to send over those juicy username and password credentials. Well, remoting actually won't let you do that by default. And there's two ways it will require you to work if you want to connect to an untrusted domain or to a computer that isn't in a domain. Way number one is to put an SSL certificate on this computer. That SSL certificate provides you with the mutual authentication. You connect to the computer, say, hey, I need a copy of your certificate, dude. It sends your certificate. You, over here, have to be configured to trust whatever certification authority issued this certificate. And that tells you, yeah, you know what? I know that certification authority's process. I know they did a good job of verifying his identity before they issued the certificate, so I'm going to take their word for it. That's really what certificates are all about. Now, a plus is that once you're over HTTPS, your credentials are encrypted. All right, so now you don't have to worry about those credentials, username and password, going in clear text because HTTPS is going to protect them. That's the preferred way. Now, some folks don't like that as much because it does require you to get certificates. You should really, if you're going to use remoting, you should think about standing up a public key infrastructure if you don't have one so that you can easily get those SSL certs. But sometimes an SSL cert is just overkill. Let's say I've got a remote machine and it's in a lab environment. This is a brand new machine. I'm provisioning it. I'm getting it set up for the first time. I don't want to have to physically log on to it to install a certificate just so I can connect and start provisioning it. So the other trick is on your computer, you manipulate something called the trusted hosts setting. And this is simply a list of names or IP addresses that you will allow your computer to connect to without mutual authentication. Now, you're still going to have to select an authentication protocol, and Kerberos isn't going to be on the table. And if you've chosen basic, then it's going to be clear text. NTLM is a choice. That's also there too. And we're going to see where to turn all these things on and off. So you'll pick your authentication protocol. You tell your computer, look, there's no way this could possibly be intercepted or spoofed. It's just impossible. I control the entire infrastructure. So I'm going to add this to my local trusted hosts. That's going to allow my computer to connect. I still have to authenticate to it, but I'm not going to require it to prove that it's who I think it is. So I'm turning off the mutual authentication. Now look, you're going to get online and you're going to see people say, look, if you're connecting to a machine that's in a different domain or in a work group and you don't want to do certificates, then just set trusted hosts equal to star, and that'll make the error go away. Yeah, that'll make the error go away. You could also walk into the high school gym and hand out your keys to whatever kid in a mask walks up to you. This is a bad security idea. In a lab environment, something like that, fine. In fact, I used to teach this class, and I used to always do this just because, we're in class, it's a lab environment, but I'm not going to do that for you here. We're going to talk about exactly how to set up certificates. We're going to talk about how to set up trusted hosts. We're going to cover all the real-world configuration for all of these different communication scenarios so that you can actually see them work. I will tell you this. If you lose track of anything and you want a nice little walkthrough, go to PowerShell.org. And in the books page, look for Secrets of PowerShell Remoting. That's got screenshot walkthroughs of all the different things I'm going to show you so that if you lose track of something and you need a quick reference to how to do one of these configurations, yep, you can obviously come sit here and rewatch the nugget, or you can just go there and it's a quick walkthrough. Now that book isn't going to try and teach you anything. It's really just a configuration reference because some of these things involve multiple steps. In fact, some of them involve enough steps that I can't even really keep them straight in my head. So I'll have that up on my other monitor while I'm walking through the configuration because I use that as a configuration reference as well. A lot of what we're going to do was established in PowerShell version 2 and hasn't really changed a ton. So we'll start here in version 2. I'm on a client computer, and that means that remoting is not enabled by default. As of right now, Microsoft does not enable remoting by default on any client operating systems. What they have done is enabled remoting by default on Server 2012 and later. So my domain controller and my domain's member computer are both running 2012, so they're going to have remoting turned on by default. But since we're on a client operating system here, we need to get that configured. A couple of ways to do it. The easy way to do it to a single computer is to be logged on as administrator and enable PS remoting. Now I'm kind of half hoping this pops up with an error, and even if it doesn't, I'll tell you what it does. This is gonna, oh, no errors. Yes, all. Okay, here's what this is doing, and then I'll tell you what that error might have been. there is a service called WinRM that is being set to start automatically and is being either started if it's stopped or restarted if it was already running. It creates a listener which will accept requests on any IP address, and we're going to talk about what those listeners are. And then it will enable a firewall exception for incoming WS-MAN traffic on HTTP. The listener that it sets up is also HTTP. And you can actually see here at the bottom of the screen this last message. This was it creating the Microsoft PowerShell 32 configuration. So the error that might have happened on client computers, particularly if you've got a client computer with like VMware Workstation or something installed, you have all these virtual NICs, all these virtual Ethernet adapters, right? Like if I run ipconfig all, I probably don't have any of the faked out virtual now because I don't have VMware Workstation installed on here. Well, what happens is those virtual network adapters get tied to a public network. You know, in Windows 7, you can tell a network to be home network, office network, or public. Well, if you have any network adapters that are identified as public and they're connected, or Windows thinks they're connected with a virtual one, it always thinks that, then the Windows firewall won't allow any exceptions. And so enable PS remoting will fail when it tries to create the exception in the firewall. So it's on you to figure that out. You've got to detach those public NICs from your system so that they're not seen as connected, or you need to reset their type so that they're not seen as public. So that's the easy way to do this on a single computer. The process is the same on Windows 8. The only difference here, let's take a look at that command, help enable PS remoting. The only difference is Microsoft kind of understood that business with the public network adapters was happening. So we've got a -skip network profile check. Now what that'll do is it'll actually create the firewall exception by default, even if you have a public network. But keep in mind, Windows itself will not allow firewall exceptions on a public network connection. So while this will allow the firewall exception, it won't necessarily mean everything will just magically work. So let's try enable PS remoting. I am sure. Whoops. Let's see here. Firewall exception will not work since one of the public network connection types on this machine is set to public. Awesome. I was kind of hoping we'd see that. All right, let me try it again with skip network profile check. All right, so there's the firewall exception. WinRM was already set up. WinRM has now been updated. It created the WinRM listener, and we're going to talk about what those listeners are. The firewall exception is enabled. And now, because I'm in Windows 8, this is actually going to create more endpoints, more session configurations. And again, going to talk about that architecture in just a sec. So the one we're creating now is... Okay, this is just allowing selected users to remotely run Windows PowerShell commands. So this is part of the security piece of this. Yes, I'm sure. And now we're setting up, so that was the Microsoft PowerShell configuration. Now we're doing one for PowerShell workflow. Yes. Now we're doing 32-bit PowerShell. Now we're doing server manager workflows. And each of those has a SDDL, security definition descriptor language, which is basically the gobbledygook here. We'll talk about that later too. And that is telling me what users are allowed to connect to this thing and actually run commands. So this is now all set up. So talk a little bit about some of those architecture pieces too. So let's say that this is the originating computer. And over here, we've got the remote computer. Now, there's a few different things going on. First of all, you are going to be connecting to the WinRM service on the remote computer. And you need to actually connect to a listener. And a listener is a combination of protocol, HTTP or HTTPS, and one or more IP addresses. So it's listening on that protocol on that IP address. Now, WinRM isn't tied specifically to PowerShell. WinRM is designed to pass messages along. So in order for an application like PowerShell to get those messages, it has to set up an endpoint, also called in PowerShell a session configuration. So the traffic goes like this. You target the particular computer with a particular IP address with a particular protocol. That attaches you to the listener. And because you're using PowerShell on the originator, there's like a little envelope. It says, dear remote computer, please pass this along to PowerShell. Well, so WinRM looks to see if there's an endpoint registered, passes the information along, PowerShell does whatever it's going to do, and the results get sent back. So what we just saw was PowerShell setting up those endpoints. Now, each endpoint has its own unique configuration, including who is allowed to connect to that endpoint, what they're allowed to do in it from a very broad perspective, and it can also preload modules, it can pre-run scripts, it can, in the case of PowerShell, it can restrict the environment so that there's no scripting language and so forth, and we're going to get into all the configurations around what you can do with those endpoints. So it's kind of important to remember that because it's completely possible to set up multiple different listeners. The external IP address that's internet accessible doesn't get a listener hooked up to it. The internal IP address that's in our DMZ gets an HTTPS listener hooked up to it. That type of thing. So you can really control the listeners, and that's all WS-MAN traffic. Then you can set up multiple endpoints that allow different people to connect to PowerShell and do different things. The next thing I want to show you is how to configure or enable remoting. In other words, enable a machine to receive remoting connections via group policy instead of running enable PS remoting. Now, most of what I'm going to show you should work so long as you've got domain controllers running Windows Server 2008 or later. A Server 2003 was not born with the correct GPO templates. Now, that said, even if all your domain controllers are running 2003, so long as you have a computer with, let's say, the Windows 7 RSAT, it comes with all the right templates and it can put them in your domain for you. So I'm just going to get into the group policy management console here. I'm going to, let's just edit the default domain policy. I'm not going to edit these things right in my domain because I've already configured everything, but I'll show you where everything is. So the first thing we need to do is get WinRM listening on an IP address, one or more IP addresses, using HTTP or HTTPS. So this is setting up the listeners. And where we're going to find this is under Policies, Administrative Templates, Windows Components, Windows Remote Management, right here, under the Service piece. Now, the name of this particular setting has changed a couple of times. It used to be called Allow Automatic Configuration of Listeners, and it's changed now. I'm in a 2012 domain. This is the Windows 8 RSAT. So now it's called Allow Remote Server Management through WinRM, but it's the same thing. And you're going to enable it, and then you enter the filters of the IP addresses you want it to listen on. And you can put an asterisk in there, and that will allow it to accept messages on any incoming IP address. So there's lots of examples down there of the different ways that you can support those filterings. Now this will automatically set up HTTP listeners. This does not give you the ability to automatically set up HTTPS listeners because there is no group policy way of connecting an SSL certificate because each machine has to have its own SSL cert. So if you're going to be using HTTPS, you're already going to be visiting each machine in order to get a certificate installed and connected. So there's no reason to do that centrally through group policy. And we also need to make sure that the WinRM service itself is actually set to run. Now look, group policy can't start the service for you. What we can do in group policy is set the service to start automatically, and then the next time that computer restarts, WinRM will start along with it. But if you need it to start automatically, you're probably going to, if you need it to start now, you probably want to come down to Windows PowerShell and do that. You can use get service, start service. You can use Windows Management Instrumentation. There's a number of different ways you can reach out to the computer and have it start that service now. But what I'm going to show you is how to actually configure it. So we're under computer configuration still. We're going down to Windows settings. We're going down to security settings. We are going to system services, and then I need to look for Windows remote management, which should be near the bottom of the list. Windows remote management, WinRM. Define this, set it to automatic, and you're good to go. So that's getting that set. You are probably going to want to configure a Windows firewall exception. So under computer configuration, let's go back to administrative templates. We're going to go down to network, and then network connections, and then Windows firewall, lost track there. And then which of these profiles you configure kind of depends on the machine. Now, I'm thinking if you're applying a group policy object, that the machine pretty much has to be in a domain. So you're probably going to be configuring the domain profile, right? So you've got one setting here, Windows Firewall, allow local port exceptions. This is right here. That simply allows local administrators to configure firewall exceptions using the control panel. This doesn't actually create any exceptions. However, that might be exactly what you want in some situations, which is why I wanted to point it out. But there's another one, which is define inbound port exceptions or inbound program exceptions, which is right here and there. So we're going to do an inbound port exception. We can enable this. We can define the port exception, which if we're just doing HTTP would be 5985 by default. So we'll set that to be okay. And so that now allows that to happen. You can do just a port, you can provide transport, you can put scope if you want it for all networks, you can limit it to specific IP addresses, you can get very, very, very specific with this. So that gets your firewall configuration. And that should be most of what you need. Now, once you've got this thing enabled, you can do some more granular management right from within PowerShell itself. So over here, I'm going to change to my WS-MAN drive. You'll see that I do have a connection to my local host, which means that remoting is enabled on my local computer. I could connect, and I forget the command, so this is a good time to do command discovery. Get command, where the noun contains WS-MAN. And we have connect WS-MAN computer name. Excellent. Let's connect to my DC. Fingers crossed. Okay, takes just a second, but now if I look at this WS-MAN drive, I've got a connection to my DC as well. CD DC. And the service stuff, the things that are WinRM related, is under service. So this is my root security. This is basically the access control list that applies to everything by default. Max concurrent operations, the maximum number of incoming connections, do not allow unencrypted. So this is an interesting thing. Even without running HTTPS, we can apply an application level kind of symmetric encryption to the channel. So it's not going to protect things like your credentials, but it will serve to at least obfuscate the traffic that's flying over the network. We've got a container for authorization. So if we look in there, these are the enabled protocols. You'll see that Kerberos and Negotiate are turned on by default. We can see our default ports. So these are default listening ports, 5985 and 5986. We've got our filters for what IP addresses we're going to allow to be hooked up. We're not turning on the old compatibility HTTP and HTTPS listeners. The first version of this technology listened on ports 80 and 443, which is kind of stupid because that would conflict if you tried to use them on a web server that was already using those ports. But if you enable the compatibility listener, then it will also listen on 80 and 443. And then you've got this sort of ultimate on-off switch, allow remote access. So those are the server-side things for WinRM. We can also go into shell, and this is stuff that's specific to PowerShell. Do I allow remote shell access? How long am I going to allow a connection to sit idle before I kill it? How many users can connect to PowerShell simultaneously? What's the maximum amount of time they can allow a session to run? How many processes can each remote shell support, and how much memory can it use? And if I've got 10 max users, let each of them open up to 30 shells. So that's kind of cool. And then on the listener side, you can see we have one listener set up. So I'll just take a look at this. It's listening on all ports, or sorry, all IP addresses to HTTP at 5985. There's no host name configured, doesn't need to be. It is enabled, and there's no certificate hooked up because it's just HTTP. Let's go back up a couple levels. There's one more section. The client section is used when I make outgoing connections. So I'm not allowing unencrypted. I can change the default ports for outgoing connections. Here's that trusted hosts thing I mentioned, and we're going to play with that later. And the authorization protocol or authentication protocols that I will use. Almost all of these settings, if you were paying attention, are actually replicated in the group policy. So you can create these things centrally in a GPO and push them out to all of the computers in your domain. So that's all of that. I don't think we really need to play with a whole bunch of those configuration settings just yet. We are going to get into some of them, but I think that's probably a pretty good overview for right now. So let's do some basic operations. Enter PS session. This is going to allow me to make a one-to-one connection to a single computer. I can give it a single computer name, and that name needs to be resolvable in DNS so that I can actually turn it into an IP address and connect to it, but it also needs to be that machine's canonical name in Active Directory. And there, I'm in. I can do pretty much whatever I want to from here, so long as I've got permission to do it. I can run commands, process. I see the results on the screen. I'm not actually doing a remote command line. That's not quite what's happening. In fact, if you look at the little pop-up, the F7 pop-up, you can see that it's my local console that's remembering all these commands I typed. When I hit enter, the command gets sent to the remote computer. It runs it, brings the results back, and displays them on my screen. If I pipe this to group get member, it shows up as a system.diagnostics.process. So, if for all intents and purposes, I'm there. The under the hood implementation is a little bit different, but I'm there. All right, so exit when you're done. Now let's do the one-to-many, invoke command. There's a couple of ways you can do this, and we're going to talk about some of the different permutations here. But the simple one is to give it a script block of whatever command you want it to run. Let's do get event log, log name, security, newest 10. Send that to one or more computers and hit enter. Boop, there you go. You'll notice in the very last column there's a PS computer name that indicates which computer each result came from. That's a neat little extra thing that invoke command does for you. Now, let's take a look at the help for this. There's a lot of different versions of this. I specified a script block. You could also give it the path to a local file. PowerShell will read that off of your computer and transmit the contents to whatever computers you specify. Now, if you need to connect to something other than the default PowerShell endpoint, you can specify that. You can specify an alternate port. So if you need to use something other than your client configured default, and if you want it to use HTTPS, it's here. If you specify more than 32 computer names, then what it does by default is it lines them all up in a queue. It will talk to 32 of them simultaneously because that's the default throttle limit. You can raise or lower that throttle limit. As it finishes, it'll go grab the next one off the queue. So it's talking to up to 32 or up to the throttle limit in parallel. Raising that throttle limit really doesn't have an effect on the remote computers because they're only doing one thing. It's your local computer. You basically have to have a thread of PowerShell running and some memory set aside for every simultaneous connection. So if you've got a workstation with 64 gigs of RAM and 4 processor cores, then you can jack that throttle limit up as high as you want to, and I think you should tell your boss that's the kind of machine you need. If you're specifying something other than the default authentication, that's where you would tell it that. You can have it hide the computer name in the output. But the computer name is still there. It's still attached to the object, so you can still sort and group and all that stuff. It just hides it for you so it doesn't show up in the output. Here's a good example of that. Let's clear the screen so this is a little more readable. I'm going to add hide computer name, and then I'm going to pipe this to format table group by PS computer name. Now look what's happening here. This is getting sent to the remote computer. The results are coming back as objects, and on my local computer, I'm formatting them. And see, by grouping them using format table, I get a nice little fresh set of table headers for each computer that was there. I could then out that to a file if I wanted to. Right? It's okay to use out file because that's one of the 3 or 4 commands that is allowed to come after a format command. So pretty cool stuff. There's lots more permutations for us to cover, so I just wanted to get these basics out of the way. And look, this is a good time. If you haven't gotten your labs set up to play with remoting yet, this is an excellent time for you to go ahead and start doing that. This is really fun stuff to play with, but it can also be a little tricky. Well, not tricky, it can be picky. This is a good time for you to start playing with it. Get these basics under your belt, and then we'll build up into the more complicated stuff. Now, while I've got you here, there's one more thing we should talk about, and that's the double hop. Not like the double tap in Zombieland. So the basic deal is this. You start here, and you establish a connection to this machine. Now that means your credential gets delegated across the network to that machine so that it can perform any tasks you ask for as if it was you. That's the way we want things. But this is kind of like getting back to loaning the keys to the car to your kid. You hand your keys to the kid, and the kid's allowed to drive the car, but the kid's not allowed to loan the keys to one of his friends. That would be another hop. For example, if you ask this second machine to perform a task against that machine, that's a second hop. Your credential by default cannot be delegated across that second hop. Now, there are certainly times when you might give your keys to your kid and say, look, don't hand these to any of your friends, but if your mom or your sister needs the keys, it's okay to hand it to them. In other words, you can specifically authorize certain machines as being allowed to redelegate your credentials, your token. And there's a couple of ways to do that. One way is to simply configure your Active Directory domain to support Kerberos delegation. Another way, which is valid in Windows Vista and later, is to use the CRED SSP authentication protocol. So let me show you where that lives. We are going to go to my WSMan drive. We're going to CD into the local host configuration. I'll CD into the client and then into auth. And you'll see that CRED SSP is a valid protocol. Now this is the client side. This is what my client is allowed to use when it attempts to make an outgoing connection. There's another version of this on the service side. And this is what it is allowed to use for incoming connections. Now in reality, I probably would configure this through a group policy, and you already saw the section of group policy that contains this. So you have to do two things. You actually have to enable the protocol, and you can run this command, enable WSMan CRED SSP. Now what you do is you run it first on the client, the machine that is initiating the connection, and you type -role client and then -delegate computer, and you create a string of the computer that is allowed to delegate your credential. Now a smart string, at least in a domain environment, would be something like *your_domain, because that means any computer in your domain would be trusted for further delegation. Now then, on the machine where you will be connecting to, across the first hop, you run it with -role server, and you don't specify delegate computer. That allows that machine to receive a read-delegatable, is that even a word, a read-delegable credential, and it allows it to pass it off across that second hop. So to take a look at this, because I really think this is something you're going to want to lock down more in group policy. Let me get over on my Windows 8 machine now where I've got these tools. There's also a domain policy you're going to have to turn on. So let's go into a group policy object. Obviously, you could configure this in any group policy object. This domain-wide thing, the first thing I'm going to show you, though, probably does need to go in your default domain policy so that this affects the entire domain. This is going to be under computer configuration. It's going to be under policies, and it's going to be under administrative templates, and then we're going to be under system, and then we're going to be under credentials delegation. And it's allow delegation of fresh credentials, allow delegating fresh credentials. So you have to enable that, and then you can add servers to the list that are allowed to do that. And there's a nice big explanation there you can read if you need to know a little bit more. So there's a couple other things. In addition to turning on that protocol, oh, and by the way, I wanted to show you that too. We were under Windows Remote Management, Windows Components. Windows Remote Management. And then we're under the service and the client. And this is where you can allow cred SSP on the service and on the client. So you can centrally configure that instead of having to do it all through there. So the other thing is, because there's definitely more than one thing, when you run some of these commands, like let's say you were going to do this with enter PS session, you have to make sure that you specify -authentication and specify cred SSP as the authentication mechanism. That way cred SSP gets used and this whole thing kicks in. Now if you'd like to read a lot more about this whole cred SSP in the second hop, that free ebook, Secrets of PowerShell Remoting, which is on PowerShell.org, really dives into this and has some screenshots to walk you through it. By the way, one of the things I should mention before I leave you is the default security. Now, this can be a little bit tough to do. Let's get get PS session configuration. That's what I'm after. So this is PowerShell version 2. So it's Windows Management Framework version 2. And you can see that it has 2 endpoints set up. What I'm going to do is format this as a table with the -wrap so that we can see everything here. The permission in particular we could pull out if we wanted to. Select permission. So you can see that on PowerShell version 2, the built-in administrators group is allowed to remote in to this machine. So essentially, anybody else who you want to be able to remote in, you're going to have to modify the session configuration. You can do that with the set PS session configuration command. You would specify the configuration name, and then you would specify probably show security descriptor UI. Here's what that'll look like. Set PS session configuration, show security descriptor UI for configuration name, now I forget what it was called. Scroll up a bit. Microsoft.PowerShell, that was it. So name Microsoft.PowerShell. What this will do, yes, I'm sure, is it'll pop this up in a GUI so you can actually see, and this is an easier place to modify this if you want to give other groups access to this particular endpoint. So no, I don't want to do anything. So that's what that looks like in Windows 7, PowerShell version 2. Windows 8, PowerShell version 3, this would also apply to Windows Server 2012. Let's run a get PS session configuration. See, this sets up more by default. I've got Microsoft.PowerShell, which is the main one, and you'll notice that built-in administrators does still have access, but there's a new group now called remote management users that's there by default. So if you don't want someone to be an administrator on this box, but you want them to be able to remote into this box, then add their user account to this machine's local remote management users. Now, one thing that I've seen customers do is, let's say they've got a help desk group and they don't want to make those folks administrators on all of their computers, but they do want to let them get in remotely and do certain things that they do have permissions for. And then in a group policy, you could actually put the domain's help desk user group, for example, into this remote management users local group on all of your computers, and that would let you set that configuration. But you'll notice that that same thing applies to the workflow endpoint. the 32-bit endpoint, and the only one that's really different is this server manager workflows. That's really only allowing administrators and the interactive service to get in. So just the default permissions so that you're aware what those are. That was quite a bit of information. We went over the theory of operation, how this thing actually works, showed you how to enable it manually and via group policy, and also covered some of its basic configuration options. And I showed you some of its basic usage. Keep those two commands in mind. Enter ps session and invoke command. We're going to be using these a lot over the next several nuggets, and they're going to come up over and over again throughout the rest of this series. So it's really important that you've got those things firmly planted, burned right into the front of your brain. I hope this has been informative for you, and I'd like to thank you for viewing.